Okay, the next problem, right here, is the same thing as saying x to the third over y to the third. Same thing, same thing. And that's actually the answer. At the very end of the last video, we stared at that for a second. We said 1 to the fourth, 2 to the fourth. Oh, same thing, and we had to simplify that one. This one, we don't have to simplify. Okay, let's keep going. All right, here's where my eyes go on the very next problem. I look at this 2/3, and I try to reduce it if I can. And if I can, I will. Well, I can't. 2 over 3 is as reduced as it goes. So I have 2 to the fourth, x to the, multiply, 16, 3 to the fourth, y to the 20, and we're almost done. And if you have numbers with exponents, it's best to go ahead and simplify them. 16, x to the 16th, 2 to the fourth is 16. 3 to the fourth power is 81. 3 times 3 times 3 times 3 is 81. 81 y to the 20th. Okay, we are about to get right into the next rule. Before we go there, let's stare at this for a second. There's an x, there's a y, those are different. What if they're the same? Well, I'm glad you asked. Before we introduce the next rule, let's kind of just tinker with it for a second. X to the fifth is x times x times x times x times x. There's 5 of those and 3 of those. Okay, back in the day, you learned to reduce things. If everything is a factor, if it's all multiplied, you can cancel some stuff out. So let's do it. Let's cancel an x with an x, an x with an x, an x with an x. Oh, what am I left with? 2x's on the top. Now, let's not call it 2x. Technically, it's x times x, which is x squared. Okay, so be thinking, what is our shortcut instead of doing this all the time, to where we could take the 5 and the 3 and get a 2? Now, you probably already know the answer to that. And as you consider that, let's move on to the next one. 4 times 4 times 4 times 4 times 4 times 4 times 4. There's too many 4s. But there are 7 of them on the top and 3 of them on the bottom. And when you do that, you cancel them. You cancel pairs. Cancel those. Cancel those. Cancel those. How many do you have? 4. 4 to the fourth power. Well, we can figure out what that is. 4 to the fourth power is 256. But the real issue here is, where did we get this 4 from? Well, 7 minus 3 gave me 4. So 7 minus 3 gives me 4. Let's flip the paper over. Let's go to the quotient rule. Quotient means divide. If I have some base, a to an m power, and a to the n power on the bottom, I have to have the same base, then I can simplify by just simply subtracting them. Some crazy mess in there if we're not careful, but that's it. All right, let's keep going. All righty. So, -3 to the fifth, -3 to the second, we can figure out what they are, but let's not. Let's actually just look at it and say, oh, I have the same base, different exponent. Let's subtract. So 5 minus 2 gives me 3, so I have -3 to the third power. And now, I'll find out what -3 to the third power is. -3 times -3 is 9. 9 times -3 is -27. That's it. All righty, let's proceed to the next one. First thing I notice, there's a 2 here. What do I do with it? Well, the exponent rules don't apply to this 2. It's a coefficient. And there's not anything on the bottom, so it doesn't reduce. So by the time you're done with this whole thing, you're still going to have a 2. There's still going to be a 2, and he's still there. That's not changing. There's a 1, and there's a 1. So let's keep going. X to the, I have 5 and 1, and I'll subtract. I'll do top minus bottom. Top minus bottom is 5 minus 1, that's 4. And then 2 minus 1, well, that's 1. I'm not going to put it, and that's it. That's what I have. What's on the bottom, Mr. Reader? Well, there's nothing on the bottom except an understood 1. All right, back to get to the very next rule. X to the third over x to the third, well, let's see. Anything divided by itself is 1. There's an exception. 0 divided by itself is not 1, but let's ignore that for now. anything divided by itself. So here's what I noticed first. These are actually the same thing. So if I had 5 divided by 5, I'd get 1. If I had 25 divided by 25, I'd get 1. If I had x divided by x, I'd get 1, as long as x is not 0. It would work. X to the third over x to the third is 1. It's fine. But if I want to do it this way, then I could also say, well, you know what? 3 minus 3, let's see, that's really x to the 0. Oh, my goodness. Okay, here's the deal. If I have something to the 0 power, then I'm going to get 1. These are equivalent. This is the answer I want, but these are equivalent. Doesn't matter what x is, as long as it's not 0. 0 messes up a lot of things. So let's come over here and we'll say a to the 0 power is 1, and in parentheses, it's important to put that, where a is not equal to 0, because 0 to the 0 power is not a thing. Here, let me show it to you on the calculator, just because 0 to the 0 power is an error, a domain error. It doesn't work. Okay, there's a reason for that, but let's move on. Aren't you curious? All right, so anything with the exception of 0. So when I say anything, I'm excluding 0, but anything to the 0 power is 1. 3 to the 0 power is 1. 5x cubed y squared to the 0 power is 1. Wow, these are easy. Negative 4 to the 0 power is 1. Negative 4 to the 0 power is, be careful, this is negative that. Okay, let's ignore the negative. 4 to the 0 power is 1, right? Final answer is negative 1. I don't know what that random dot is for. Ignore it. Ignore that right there. Don't stare at that. Anyway, 4 to the 0 power is 1. It's negative 1. Oops, that's what I was trying to do. There's a negative 1. Sorry, that was confusing. Final answer is negative 1. But I thought anything to the 0 power was 1. It is, but there was a negative in the front that changes it. And similarly with here, I have 5 times this stuff. This is 1. So I have a 5. Okay. Well, that covers pretty much everything, but there are 5 problems left on here where we have different rules for different things. So let's do them. In a situation like this, we are multiplying, and that means it is a product, so we should add our exponents. So let's do it. First thing, negative 2 times negative 13 is 26. M to the 1 plus 8 is 9. 6 plus 1 is 7. Okay? Next problem. We have a couple things going on, and actually before I even start the problem, I'm going to do something that we haven't done in this lesson yet, but I think it's easy to do and fair to do. 3 over 6 is a fraction that reduces. So before we even start, let's reduce it. 3/6 is the same as a half. I'm going to leave the 1 off because it's understood. There we go. That's what we have. It's the same thing. It's perfectly legal. You can do it. 3 out of 6. If I have 3 over 6, y'all can't see what I'm writing. It's the same thing as a half. There's an understood 1 in the front there. It's fine. Okay. This rule, I would say it looks like a quotient, like I'm dividing because it's a fraction. I would say it's that, but technically it's that. And here's the reason why. If I'm dealing with the quotient rule, or any of these, without exception, if I'm dealing with any of these, I have to have the same base. They have to both be the same variable or the same number, and in this case, this one's a y and this one's an x, so it's really not. But what I will do is say, ooh, a power to a power, multiply. And then 2 to the third, we'll figure out what that is in a minute, it's 8. And then 4 times 3, power to a power, multiply. And then, let's simplify, we're almost done. Y to the 15th, 2 to the third is 8, x to the 12th. That's it right there. Okay? Oops. Now you can see it. 3 more problems. We're almost done. 9 to the 0 power. 9 to the 0 power is 1. That's to the 4th power. Plus z to the 0 power, we're assuming z is not 0. Z to the 0 power is 1, and that's to the 5th power. 1 to the 4th power is 1. 1 to the 5th power is 1. 1 plus 1, I'm pretty sure that's 2. It gets easy at the end, but it's confusing at the beginning if you're not careful. Next problem. Okay, before I even start, I like to look at the coefficients and reduce them if I can. If I had 9 out of 27, I would divide, 9 goes into that 1 time, 9 goes into that 3 times. It's 1/3. You can put the 1, I'm not going to. Here's what I'm really about to do. I'm about to use the quotient rule. And we're going to subtract m minus n in this situation, or 4 minus 1, 3. Obvious question. How do you know if it goes on the top or the bottom? If I do numerator exponent minus denominator exponent, if I do top minus bottom, I'll put it on the top. So top minus bottom goes on the top. And that's it. There's an understood 1 here. That doesn't reduce or simplify anymore. Last one. This is a power to a power. We have negative 3 to the third. Whoa, put it in parentheses. We have x to the third. We have y to the, whoa now, 6. And z to the 9. Okay. Negative 3 to the third is negative 27. X to the third, y to the 6, z to the 9. And that's it.